Good morning, Lieutenant Colonel Chris Collins. I am the Senior Military Analyst for Studies and Analysis Directorate number 3. Before I talk about my background, I'm taking a look at who's on the line here, and I see there's a good mix of my coworkers as well as people outside of TRAC. So I'm going to gear this discussion on professional development internal to TRAC based on the audience that I see here, at least online. So a little bit of background about myself. I've been with TRAC for going on 5 years. So what do I mean? So I came to TRAC. I switched from combat engineers into what's called ORSA, or Operational Research System Analyst, or an FA-49, when I was a senior captain after what's called company command. And I actually ended up going to TRAC, and I went to TRAC Fort Leavenworth, and I was there for 3.5 years as a senior captain and then a junior major. While I was there, I definitely took advantage of a lot of the professional development opportunities, and that's why I'm a big proponent of it. After that, I was able to go get my master's degree from K-State University in operational research, and then I parlayed that into teaching at the United States Military Academy at West Point for about 4 years, where I taught calculus, I taught probability statistics, and several other courses as well. And I loved the time there. I loved the opportunity to get an academic environment. Then the Army said, hey, that's enough of that. And then they sent me to Afghanistan, where I was an analysis branch chief, in which I actually got to apply a lot of what I'll talk about today in a real world application in a 4-star headquarters, where I was the analysis branch chief for Resolute Support, which is our mission there in Afghanistan. And I got to do the data analysis, the real world data analysis based on the statistics that were coming out, troop levels and that kind of stuff. At that point, it came on, hey, the Army asked me, where do you want to go to your next assignment? And I looked back on it and I said, I really enjoyed my time in TRAC, and I liked it to come back to TRAC, which I think is an indication. And I always tell a lot of senior or junior, major, senior captains, look, I'm a testament to it. I love TRAC so much that I liked it to come back. So that's the perspective I'm going to be talking about. And one of the things that TRAC does really well is professional development. So what do I mean about professional development? Well, professional development is obviously, it's just like anything. It's the technical skills you have are perishable. And it's important as an organization that we expect you to invest in yourself, but we're also going to invest in you. It's a mutual relationship that we have. So as you look on your screen there to your left, you see how the Army does it. And they say there's this operational domain, there's this institutional domain, and there's this self-development domain. And if you notice here, it's a really cool Venn diagram. And at the intersection there is the leader development or how the Army looks at leader development. Parallel to that, or to the right, you see the TRAC professional development model. And how TRAC looks at it is that we expect you to come to TRAC with a set of skills. Now, of course, it's dependent on what you were hired or brought on. Doesn't mean you necessarily have to stay there, but we expect that you have at least a foundation or bedrock of certain skills. And what we are going to do is we're going to train you to some degree. And this is applicable for both civilian and military. And again, it's whether you're in TRAC Leavenworth, TRAC Lee, TRAC Monterey, or TRAC-WSMR, professional development doesn't stop. So there's really 3 ways that we do professional development. And you can see it's paralleled over there to the left, how the Army does it. But we're going to provide training, again, just on-the-job, hands-on training, advanced education, and experience. Now, I think these things are rather self-explanatory, but nonetheless, it's pertinent to look at them. And when we come here, if you're just out of college, which a lot of you are, if we're going to put you in a position, we're not just going to give you something and go. We're going to provide you training or an apprenticeship. So when you join TRAC and you work in one of the studies analysis directorates or modeling directorate or another operations directorate, we're going to assign you as an apprentice. And those are support, or you're an analyst for it. And it teaches you the TRAC model, TRAC methodology, as well as the tools associated with it. Concurrent with that, you develop experience or supplemental experience, which is all the way to the far right on the screen there. However, in between those margins, or we'll cut out the time for you, we also expect you to do advanced education. And TRAC's on the hook for this, and you're on the hook for this. And one of the opportunities I'm going to talk about is the one that TRAC does specifically. But nonetheless, the advanced education, you can professionally develop yourself in terms of leadership, and there's leadership courses available. There's operational courses as well, going out to an operational environment and taking a course there. But the one I want to talk about is the technical, and how do we professionally develop you in the technical sense. And so the way that we're going to professionally develop you in the technical sense is what you see here, and it is the data science lecture series. Now, as data science lecture series, again, we love Venn diagrams. I do, especially as teaching probability statistics. I'd get a -1 here, however, because in my Venn diagram, I don't have an S in the top left corner, which doesn't indicate that all my possible outcomes are indicated in my sample space. But notwithstanding that, so who is this available to? The Data Science Lecture Series is available to all TRAC team members across all centers. And what it is and when it's done is it's a twice a month professional development series in which we take 1 hour classes, usually around noon. And it started in November. It's going to run all the way through June of 21. We record the lectures because we recognize that not everyone's always available during that time. And there's a both synchronous and asynchronous way in which we teach the course or provide the lecture series. It's all done on Microsoft Teams. So going back to the left hand in my unacademically pure Venn diagram, in terms of data science, I myself am a mathematician, specifically a statistician. So under the mathematics realm, I'm more of the statistical research side. However, being an ORSA, again, operational research system analysis, it's composed of a lot of different functionalities. So within this, we have mathematics, computer science, and then domain expertise. And that intersection creates what we call data scientists. And that's what this lecture series is developing the attendees to develop the skill set there. Because again, it's perishable. It's taught at it bridges the gap between undergraduate and graduate education. So it's that bridge in between there. And how it's broken down in terms of the disciplines that we cover, you can see that we cover down on computer science, probability, statistics, calculus. That's right, calculus. You can't get away from it. Linear programming, and then operations research pure. And you can look at the number of lectures that we have assigned to it. So again, a little bit heavy-handed on the computer science, or that right side of it. Probability, statistics, calculus, and linear programming, that's all on the left side. And the operations research, we have one class on the northern side of that, domain expertise. Again, the intent behind this is to provide a professional development opportunity for our workforce, in which our leadership allocates the time for us to do it, or if you're in the middle of a project, you can watch it asynchronously. And the intent of this is to build your toolkit, is to hopefully bridge that gap between your undergraduate education and your graduate education, depending on where you are, and provide you tools for your toolkit. And what do I mean by that? Well, for this course, we exclusively use RStudio with minimal exception. Now, again, there's a lot of different programming languages out there. The Army is moving away from Excel into RStudio, at least in the ORSA realm, in terms of the data scientist realm. Python's still applicable. Some people prefer that. I think my preference is RStudio, and a lot of the Army's preference is RStudio as well. That's just where we're teaching it from. Again, we teach the coding for R, but just like anything, we provide pseudocode, so you can translate that into Python if that's your preferred desirement. Again, so the idea here is that we're going to provide this linkage, and then we're going to provide you a hands-on opportunity. We're going to provide you the code. We're going to provide you a data set. We're going to ask that you manipulate it there in order to build up your own toolkit. So that's a quick overview of it. Now let me show you just an idea of what we've done and what we're doing. So this is our entire data science lecture series course. Again, it started in 5 November, and then here we are tracking on April 21st. So next week we're going to be looking at how to deal with messy data. But thus far we've done quite a bit. Again, we're rounding third and sliding into home here very shortly. And again, it all starts with the analytical question, and it was derived based on what we've seen around the workforce in terms of why would I use this or why is this applicable, and then the associated task condition standard with it. So in terms of the analytical question or what we cover down on, there's quite a bit, and you can look at for example, on the 14th of June, we looked at this idea of something called bootstrapping. What is bootstrapping, and where is it applicable? Well, let's just say that you have a data sample and you have a very small data sample size, like let's just say 6 observations or 10, and you want to do parametric, again, where you can use central limit theorem. You want to use parametric. Again, there's other options here as well. This is just some of them. Well, what we're going to cover down on, what we covered down on, is this idea of how to do bootstrapping with it. So how to make your data sample, or how to make your sample more robust in order to conduct some additional data analysis on. So how do you analyze small sample sizes? And discussion is exploratory in nature. Here's my small data sample size. Let's plot it. Let's take a look at it. Let's see what we can do with it. And if we can, let's go ahead and do this bootstrap or populate more samples within the samples with replication in order to provide just a wealth of just more robust data, and hope for us to eventually do some parametric or use this central limit theorem in order to derive or do some data analysis. Tracking down on this, you can look at the topics here: single and multiple linear regression. I think that's very tangible for a lot of the people here on the line. Hypothesis testing, think two-sample t-test, pair t-test. How is that applicable? We did Likert scale data analysis. That's one of my I think my sticking points, or one of my bugaboos, especially as you go out in the field. And when you go out to the field and you're supporting a study, the expectation is that you are the subject matter expert on these. And even if you're not, your team, someone on your team should be able to fall in on one of these topics. So just recently, when I was in Afghanistan, there was a lot of sample data in which you used a Likert type scale. Think of responses: hey, I moderately agree, I strongly agree, I strongly disagree, right? So the scale 1 through 5. And what I saw what they were doing is that they were pulling taking the average of that Likert scale data and reporting it as gospel. And if you're listening to this, you're saying, yeah, that makes sense. Well, then this class would have been a good opportunity for you to discuss the finer points of that. Why is that not applicable? And it's really not applicable because Likert scale data doesn't inherently have any value. It's what's called nominal, ordinal in nature, which means that there is no, what is the difference in terms of quantification between I moderately agree and strongly agree? Think about when you do hotel ratings or Amazon review ratings. What's really the difference between 4 and 5? Probably that it got shipped late, but is that the same standard for each person? And the answer is probably no, right? On one end of the coin, it's easy to hit all the 5s. Some people like the 3s. What is that difference between them? It's not interval data. So how do I analyze Likert scale data? Well, we discussed that in this class here as well. So what this lecture series ultimately does is you look at the analytical questions that we cover down on, the classes, and then really the end state, what you should walk away there from, is really these skills. So that when you go out to the field and you're supporting a study, or you're on a team that's supporting the study, that you are not only able to apply what you learned, but going back to that genesis in terms of the education, that you're aware of it. When you leave here, you're not going to be an expert with it, but at least you'll put that nugget in your head. You'll say, oh yeah, I remember that I should not take the mean or the average of Likert scale data and report that as gospel. Now, again, just like everything, there are times that you can do that. And if you, in the discussion of that, we discussed that in the Likert scale data, if you have a large enough robust size, 1 through 10, but nonetheless, I diverge. So this is really an overview of the data science lecture series, where we are, and then where we've been, and then where we're going. At the bottom there is some cool output. Again, all R. These are all example R output from lecture series. You see some box plots, you see some scatter plots, and then you see some cool summary statistics. And some of these I'll show you here in a second. So what I want to do is just provide a quick exemplar of some of the skills that we cover down on. Again, it's not exhaustive. It's not the breadth of it, but just talking about sort of what we're talking about, the skills that we've covered down on thus far. So I provide here a notional, completely made up analysis in which we collected samples for the TRAC-WSMR rifle. And I think that's a Fortnite rifle there. I just pulled it from the web. And what you see here is the data that we collected for it notionally. Again, I created it. But going from left to right, we have the system, the TRAC-WSMR rifle. It looks pretty formidable, but we want to find out really how good is this rifle, right? What is it? How good is it? So we have the dates in which we had people out there firing it. We have the distance in which the target was, how long in seconds for them to identify the target. Conditional, once they identified it, the time to engage it. So it's conditional, something to remember. The experience of the operator. So again, that's anywhere from 1 to 15 years. The MOS, which is just the military occupational specialty of them. So there's 3 listed here. There's an 11 Bravo, which is our infantrymen, our 88 Mikes, which are our wheeled vehicle operators, and then our 12 Kilo, which is our plumbers in the Army. We have the wind speed, anywhere from, I think, 6 to 20. Whether or not a malfunction occurred, and again, this is categorical in nature, it's going to be either 0 or 1. 0 if there's a malfunction, and 1 if there's a malfunction, 0 if there was not. And then whether or not the target was hit. And again, that's a binary or categorical variable. It was either yes, you did, or no, you did it. 1 if you hit it, 0 if you didn't. So the sample size is n is equal to 134. So it appears to be a fairly robust sample here. And ultimately, I want to answer, hey, how good is the TRAC-WSMR rifle? So I immediately plug this into R. I spit out an output, and I say, boom. The times that I hit target, or I just take the mean, I hit it 108 out of 134 times, or about 81%, right? So we high five, it gets a B-, and the study's done. Well, not quite yet. Does this really articulate the data set? Did we underwhelm it? We may be answering a question, but it's not really the question that really answers on this rifle, the so what from it. And really what we care about here is what factors influence the accuracy of the TRAC-WSMR rifle, which is maybe something we should investigate just a little bit further. So we're going to do some exploratory data analysis. In 2 lessons before me, you saw Mr. Dickerson do some spreadsheet analysis. And here I just quickly read this in. So along the top right-hand corner is my R code. I like it in this black view. It's not the standard view. It makes me feel like I'm in the Matrix. So I read it in, and I run a package called get summary. And I read this table in, and I just bifurcate it, which means I just categorize it by whether or not I hit the target, and then I plot it out. Well, along the top characteristic, I have 0 if I missed, 1 if I hit it, and it's conditioned here. And as I scroll down along this, I start to get an idea of what's going on with the data. And again, based on familiarity of time, I just went ahead and highlight it. And what I see here in terms of the whether I hit or miss, I have really 3 days. I have 2 distances, time to identify the target, and so on and so forth. But as I look down on really, hey, what factors either influences me to hit it or not, I start to see that 19 of my 26 misses were at a distance of 800 meters. Okay, that's something interesting to look at. The time to identify the target, time to engage the target, median, right? Really not a really discernible difference between the two. I can't say they're statistically significant, nor is there a difference in MOS, right? So there's really no difference whether you're an infantryman or a plumber in the Army. If you're in the Army, you're going to be able to shoot a rifle. Sounds good. But then as I further look down, I see at the wind, I see that 22 out of my 26 misses occurred when the miles per hour was around 20 miles per hour. So maybe there's some correlation there. And then if there's a malfunction, there's quite a bit of misses too. So now in my head, I'm able to start to say, this provides me something to do some further data exploration on. Another cheaper way of doing this is I can just run a pairs data analysis. And again, this is the actual code. Just 1 line of code, I get this. And again, it's a little bit of an eye chart. You're like, whoa, bad thing happening. I'm not going to spend the time to talk through what's going on, but I can say there's some complementary things associated with it. As I look at the date distance, I noticed here, and as I look at the pairs data to the right, again, don't get confused, don't get taken aback by the eye chart. I see there's different types of data. I have categorical, I have discrete, I have continuous random variables or data, but let's get into that here in a second. So I do some quick data exploration. Again, the code here would have been relatively light, but I like to color code these things. And as I look at my data there to the left, I have my time to identify the target, time to engage the target, and time to, or the experience of my operator. So as I look at the time to identify the target and the time to engage the target, what kind of distribution do I see here? Can anyone tell me? No. Anyone, what kind of distribution does that look like? Oh, okay, cool. I heard you say it there, but you had it on mute. Right, so what you have here are exponential distributions. Really, you're gonna identify this target in a short time period, and the further away I get as time goes on, it happens really up front or it doesn't happen at all. For the experience of my operator, it's normally distributed. It looks a little bit skewed negatively, but that's probably because people long in the tooth aren't going to be out on the range at the same rate as the younger folks are, or at least not get suckered into doing these types of field environments. Another different way of me just looking at this data is to look at a box plot. So I take a look at the box plot, and I see that the time or the date here, so there's really 3 days, 23 or 22, 21 through 23 April 2022, so that way you know it's notional. And I just do a box plot here, and again, look at the R code for this. Really one line. And I see here that really there's not a discernible difference between these. And I really don't want to look at these predictor variables as providing really any analysis point, at least for the sake of what I want to look at for hits. So I look at some other data exploration analysis. So I'm going to apply some multiple linear regression. And there's the academic view of it. Looks like some cool numbers. But in terms of R, the coding here is that I say, look, I want to create a linear regression model for the hit of the target, looking at all the different predictor variables. And when I run it in R, I highlighted there, I did it for us. I get an adjusted R squared of 0.76, right? So right away, everyone's saying, hooray, yeah, R squared, or adjusted R squared of 77%. That's awesome, that's great. This model is good to go. And yeah, sure, why not? There's some other things to look at, but when I look at those other things, I say, let me just graph this, let me just check this out. Boom. So what I have scheduled here is my actual hit, probability of hit, and then my predicted hit. And I say, that doesn't look good. Nope, not good. And why is that? It's because my response variable hit is not a continuous or discrete random variable. It's categorical in nature. So a better way for me to have looked at this is using logistical regression. One of my more favorite plots or ways to do it. So logistical regression is better articulated as what is the probability that I hit the target given the predictor variables X, Y, and Z. And I did the math for us, and the better predictor variables here are predictor of wind, of distance, and then the time to identify the target. And again, look at the code here. 2 lines of code associated with it. I hit run, and it spits this thing out. If you're not familiar with logistical regression, this looks like a lot of gobbledygook. It is. But fortunately, R allows you to quickly figure some stuff out. I quickly figure some things out, and I get this this S curve, which sort of looks like up top here. And why is it not all the way? Why is it all the way not connected? And that's because I have some categorical predictors in there as well that allows it not to be a continuous curve. Not a big deal, however. So I can take a look at the output here, and I can really validate whether or not this is a good model. Can I predict whether or not I hit, and what are those predictors that allow me to articulate whether my rifle is accurate or not? And those predictive variables are, again, wind speed, distance, and time to ID. So I pull the data here, and I say, hey, what are the odds? What's the probability that I can hit it? Well, I got to calculate the probability or the log odds of it first. Calculate it. I just pull one example. So I pull that very top line. And I say, for this system, If my distance, I'm sorry, my first one is wind speed. If my wind speed is equal to 8 miles per hour, my distance is equal to 400 meters, and my time to ID the target is 4.31 seconds, what's the probability that I hit the target? Well, in this case, we've already trained the data, so we're just going to do a quick test. And when I test my data, and I plug this in, and I evaluate it, my log odds are 3.1. I do a transformation. My odds to hit then become 22 to 1. And the probability 22 to 1 is 96%. So that's pretty dang good odds. So it validated that. So let's find an example where it didn't hit. So here's an example of where it didn't hit. And I substitute that data in. And when I substitute that data in, I find that the probability to hit was actually equal to 0, given the conditions of 20 miles per hour, 800 meters, and 3.36 seconds to identify the target. So in terms of just a 2-sample test of testing my data, I found that this validated the model that I provided. And again, I rushed through this principally based on time, but just to articulate, this is sort of the scope of what we cover down on. So in terms of just data exploration and data analysis for this professional development opportunity, ultimately data science is an art, and as part of this course, professional development, we give you the technical skills, we mix it in with the art. And it's really the art of it, the technical knowledge, you got to have that, know where to apply it, and then the expertise associated with it. You got to know your data set. You got to be a domain expert. Each problem has its own unique solution. There's really not a single acceptable method. Again, no statistical significant relationship between X and Y is still a solution. It's a solution of sorts. Your boss may not like it, but the data speaks for itself. Mark Twain always says there's lies, damn lies, and statistics. Fair enough. And then really the big point here as I'm wrapping up is the accumulation of knowledge doesn't end on graduation, either from college, graduate degree. As an organization, we continue to push it forward. We've sponsored these opportunities. We want to make it approachable for you guys. So a little bit over, I didn't really give you guys a lot of time for question and answers because I didn't want you to ask me why I chose this logistical model, but I'll take a pause and see if there's any questions. No questions. Okay.
Yeah, not seeing anything, but that was a great presentation, Colonel Collins. Thank you so much. I really like how you emphasized the fact that TRAC does continue to build upon the academic career of the employees. And your presentation really brought that home, I think, for everybody. If we could go ahead and switch the slide deck for our next presenter. Christina, can I get a comms check with you?
I can hear you, Steph.
Perfect.
Sarah,
thank you.
Are you going to bring up the slides or do you need me to bring them up?
I'm working on bringing them up right now.
Thank you.